There is no general definition for nanomaterial, so different definitions cover different materials. I think what they all have in common, it's somehow about particles being small. And small means in the nanometer range, defined from 1 to 100 nanometers. And one dimension of that material is in that range, or 2 or 3. What they have in common, they are produced to be nanomaterials. So on purpose, they are that small. Obviously, other particulate stuff can be nano as well. Milk, good part of sand can be nano, but it was not produced or intended to be nano. Obviously, nanomaterials have different properties, at least those which are produced in the nano range. That's why they are produced in the nano range, to achieve different properties. High surface for catalyst, different color, material properties. And new properties may cause different toxicological effects. And that's maybe a concern which comes with every new property or new material or new technology. Do they get into the body because they are so small? Do they have different effects in the body because they have such a large surface? What happens to them in the body? So it's a question, and toxicology has to answer it. When it came up 10 years ago, there was the idea, well, because they are small, because they are so new, also the technology was hyped, so it was something exotic. People suspected something very special, very unique to nanomaterials. So in a way, a specific nanotoxicology only nanomaterials would have. And this, I think, with now 10 years of research, we realized that there's no magic, mysterious, or specific nanotoxicology. So in other words, there's no toxic effect with nanomaterials which is not known with any other material. I think nanotoxicology was from the start very good in taking concerns serious, answering questions, doing studies, doing a lot of studies, and hence learning what was a conception and what was a misconception. And we learned, well, nanomaterials are different, maybe have a different potency, some have different effects, may reach different parts of the body, but in general, nothing new. On the other hand, nanomaterials are different from each other. There's no nanospecific toxicology for all nanomaterials, but each nanomaterial may have its own toxicological profile. We realized that there's an urgent need to come up with an idea how to do risk assessment of nanomaterials without testing each and every ever so slight modification of a material. And that's when ECETOC started working on it, because ultimately we would have to test all and each material, and that can be a lot. Is there a possibility to group nanomaterials together with the same or very similar toxicological properties? Well, we started out with looking at what's already out there. So what tests are used, what concepts are used for risk assessment, are there concepts for grouping of nanomaterials and of chemicals, and are they applicable to nanomaterials? That was summed up in a review paper and published. And based on what we learned from there, we established a concept we call it decision-making framework for nanomaterials, how to test nanomaterials and use the data we obtain to do grouping and then risk assessment of nanomaterials. That is a theoretical framework, a decision-making framework. Right now we try to test it. We try to put it in practice. We take different nanomaterials, put them through our decision-making framework and see what the outcome is, and then compare it to the toxicity data we have. So obviously we use materials where we have pretty good toxicity data, but it is case studies to prove or verify or disprove the concept. They have the competence, and I'm very happy with the task force. We're making good progress. Then I think things like this you can't do by yourself. You need an exchange, and the task force is one thing. I mean, we discuss, we have ideas, but we are seeking, and we are also being sought for discussion with others, with research projects who work on nanosafety, with authorities who work on nanosafety. So it is something which is done interconnected with others. We have to have a risk assessment of a nanomaterial, and we as an industry have to have it because we produce it. We have a responsibility. Authorities need to have it because they regulate it. Academic research is interested in what data and what research fields, so we're all together. 10 years ago, when nanomaterials were new and nobody really knew what to test and whether you did enough, and however much tests you did, somebody could come up with a new idea what to test, and you were never sure whether your assessment is good enough. That's what a framework is for. Give you guidance, do this and this and this, and then you get information and ultimately a risk assessment.